So for our next example, children in a large city are classified based on the neighborhood school they attend. A random sample of 5 schools is selected, and all the children from each selected school are included in the sample. So when we look at this, we have a sort of classification going on, and then we're choosing out of that classification. So we know it's either going to be cluster or stratified. Now if we look at the neighborhood school that somebody attends, is this a characteristic of the actual children in the schools, or is it just based on an area? So to me this is more of an area, and so I'm going to call this a cluster sample. Okay, again, because it's based on area rather than characteristics of the students in the population. The next one, the first 30 people entering an opera house are asked if they support an increase in funding for the arts. So here there's really no system going on, it's just, hey, let's take the first 30 people. And so this is definitely going to be a convenience sample. This has a huge chance of being biased because, you know, if you pick the first 30 people, maybe those people have a definite love for the arts because they're there first, and so of course they're going to support an increase. Moving on, letter E. It says students at Portland State are classified according to their major. Then a random sample of 15 students from each major is selected. So now we're doing another sort of classifying. So it's either cluster or stratified. Now this classification of a major, is it based on an area or is it based on, a classification, a characteristic of the specific students? So since this is based on a characteristic, we're going to call this a stratified sample. Okay, because it's based on a characteristic. Alright, in our next example, we want to describe how we would determine a sample of 5 students chosen from the entire contemporary math class. So we're just going to use the students here as the population, and we want to be able to select 5. So maybe I want to look at the last test that we took, and I want to look really in depth at the questions to see where students are struggling. Now if I did this for all of my students, that would take a really long time. So instead I want to choose a smaller sample of only 5 students so that I can really dive deep and then make some generalizations about the entire class. So that would be kind of why we would be doing this. So for a random sample, okay, the entire class is given numbers, and so we're given, I think this class has numbers 1 through 20. So there's 20 students in a class. Now what we want to do is come up with random integers from 1 to 20. Now if you're working on the TI 83 or 84, here's how you do it. You go ahead and hit Math, and then select PRB for probability, and then you select rand int. So it stands for random integer. It opens up a parentheses for you, and then you put in your first integer, and then comma, then you put in your last integer. And then you just hit enter as many times to get the specific numbers that you need. Now it's also cool because you can use Wolfram Alpha for the same thing. So we'll just start up our internet here, and we'll go to Wolfram Alpha. Now when you're using the calculator, you'd have to enter 5 times to get your 5 numbers. With Wolfram Alpha, you can get a random integer. So you would just say random integer, and then you could give it the range from 1 to 20. And it'll understand what you're saying here, and the result was 3. So in this example, however, we want 5 random integers. Okay, so you can just type the number 5 and it gives you 5 of them. So numbers 9, 10, 6, 18, and 4 would be a part of my sample. Okay, moving on. For systematic sampling, in this case, the classroom is divided into rows of students in their chairs. Okay, however they are. And so I can randomly choose the first number. I think Wolfram Alpha will just use the number 3, so that's where we're going to start. And if I want to make sure I get 5 samples and that this goes all the way around, if I have 20 students and I divide that by 4, it gives me 5. So I could choose every 5th student, and that would make sure that I get all the way around. So let's start with the third. Okay, we'll select that one. And then we want every 5th student. So 1, 2, 3, 4, 5. So I could choose that student. And then 1, 2, 3, 4, 5. Choose this one. And then 1, 2, 3, 4, 5. This student. Notice I didn't quite get all 5 students, so you just start back at the beginning. 1, 2, skip this one, 3, 4, and 5. So there I would get my 5 samples. Next, for a cluster sample, again here I could divide the class into areas, and it would probably be easiest just to divide them by the rows that they're in. Okay, and so we have row 1, row 2, row 3, row 4, and row 5. I would use my random number generator to pick one of these. We'll just use the same number 3 that we got from Wolfram Alpha. And so what that would mean is I would just select all the students that were sitting in row 3 to be part of my sample. Now it's a little tough. If I want to get 5 students specifically, I may have to tweak some things. Maybe I would select 2 groups at random and then pick out of those 2 rows. But the biggest thing is to divide the class into sections and then randomly choose out of those sections. For stratified sampling, okay, we could just pick some sort of characteristics to split everybody up by. So let's just say types of shoes. So I just quickly survey the room, and we see some kids are wearing athletic shoes. Some students are wearing sandals. Some students are wearing boots. And some students are wearing some sort of slip-on, Van type shoes. So we have to make sure that the entire population fits into one of these categories. Then we could either determine the percent of students in each category and try to choose based on that, or we could choose one from each type. So if I want 5 students, let's just make it nice. Let's say that they're also dressy shoes. And then I would just choose 1 student at random from this group. And again, you're going to use the random sampling to be able to choose the random students out of each of the groups. So that's where random sampling is kind of confusing because it's actually involved in all of the processes. But anyway. And our last one, convenience sampling. This would be the easiest. I would just wait outside the door, and I would choose the first 5 students to enter the room. Okay, notice this has chance for bias because maybe the first 5 students to get there are the most studious, so their tests may not be representative of the whole class. Or maybe I just picked up the first 5 tests that I graded. Okay, that would be very convenient for me. However, it may not give me the best overview of my entire population. So it's very important as we do this gathering of information to be very clear about our sampling techniques and how we use them and how best to come up with that unbiased sample. All right, that's it for today.